In some cases, if we use simple microscope, then the requirement for simple microscope would not be sufficient to minimize the aberrations like spherical as well as chromatic. Thus, if higher magnifying power is needed, we should go for more than one lenses, and this type of instrument which use more than one lens in the microscope is called as compound microscope. Okay, in case of compound microscope, we use two different lenses. In this case, if we see this diagram, AB is the object kept at distance of f and 2f. It is kept between focal length f and its twice distance for a objective. Objective is the lens which is facing the object. Okay, that's why it is called as objective. And eye lens, which is eyepiece, which is kept near to the eye of the observer. So this instrument is kept in some type of, we can say, this is the instrument having diameter of about 4 to 6 millimeter. Okay, because some smaller lenses are fitted in this instrument. Objective and eyepiece are adjusted so that they can be moved variably, and we can get the clarity in the image of small objects. Okay, in compound microscope we can see very small objects of having sizes about 10 raised to minus 1 millimeter to 10 raised to minus 3 millimeter also. So because of this, the image would be immaterial, and there is very large size of magnification can be seen when the rays of object emitting from the objective will create its image at a dash b dash. We can see in this diagram a dash b dash is the image created by the objective, and then this image will work as object for second lens, that is eye lens. Further, this eye lens will create the second image a dash dash b dash dash. Okay, and that is very large image as compared to the size of object. तर ऑब्जेक्टच्या साईजच्या कंपॅरिझनमध्ये इमेजची साईज जी असेल ती लार्ज असेल. इफ यू कन्सिडर द व्हॅल्यू ऑफ बीटा इज द angle made by eye lens rather by image created a dash dash b dash dash. That's why tan beta is equal to a dash dash b dash dash upon v. V is the distance of the eye lens from the objective. And also value of tan alpha would be ab upon d, that we have already seen in previous diagram also of simple microscope. In simple microscope we have seen this diagram for visual angle alpha. Here tan alpha is equal to opposite side AB upon adjacent side D. That's why tan alpha is AB upon D. We have considered that value in this equation. So magnifying power M is equal to beta upon alpha, and if we put these values of tan beta and tan alpha, then after sufficient calculations and putting these values, we have the value of M as M0 into ME, where M0 is linear magnification of the object created by object rather, and ME is the angular magnification, or we can say magnifying power of the eye lens. Okay, the MO is the magnification of the objective, that's why the suffix O is used, and E is for eye lens, that's why magnifying power of eye lens is given by capital M, capital ME, and the product is magnifying power of the compound microscope. Okay, here capital L is distance between two lenses, VO plus UE. V is image distance of object from object, and object distance UE will be UE for eye lens rather. So this is about compound microscope. So we have to study this diagram very accurately so that we will consider the process how image can be magnified by using large number of lenses. Even in simple microscope we use only single lens, but when such lenses are responsible for making chromatic and spherical aberrations, then we can use more than one lens, then compound microscope is useful. So this is how optical instruments like microscopes can be used in optics. So that's all for today. Thank you very much.